Alright, in this video we are going to talk about matter. And matter is simply anything that occupies space and has mass. So pretty much everything in the universe is matter. Now, matter, if it's a specific instance of matter, we call it a substance. So air, water, or sand. And we classify matter according to its state or what physical form it's in and what it's made of or composition. Now, in this class, we're going to talk about three different states: solid, liquid, and gas. There is a fourth state, plasma, that we're not going to talk about. And you can change between these different states just by changing the temperature or pressure. Now let's take a look at our different substances. So here we have solid. All the atoms are close together. Liquid, where the atoms are still close together, but generally not as close together as in solid. And gas, where all the atoms are very far apart. Now, the question for you to think about is, we know day to day, atoms and liquids and gas move. Now, do you think atoms and solids move? Why or why not? So take a second to think about that. And the answer is yes. Atoms and solids actually do move. They are vibrating all the time. The only time something doesn't move if it's at 0 degrees Kelvin or absolute zero, which never happens in the real world. So even though the table you might be sitting at doesn't seem to be moving, all the atoms in there are actually vibrating. Now let's talk about solids. Solids have a fixed volume and rigid shape. The atoms are in a fixed location but will vibrate. Some examples are ice, aluminum, or diamond, or anything else that's not a liquid or a gas, obviously. Now, we have two different types of solids. Crystalline, which all the atoms are in a fixed pattern, and they're long-range repeating pattern, as we see in quartz, or amorphous, where there's no long-range fixed order. In glass, there's really no order to glass. Again, another question for you to pause and think about. Do you think table salt, sodium chloride, is crystalline or amorphous? How about the plastic used in water bottles? So again, take a second to think about it. And the answer is salt is crystalline. You can see if you look at salt crystals, as even the word salt crystals, underneath a microscope, you have a pattern of sodium and chloride. While the plastic and water bottles shown here is amorphous. There's no fixed order, no long-range patterns. Now liquids, the atoms and molecules are packed almost as close as solid, almost. Now, the way to think about that is, imagine you are trying to compress a solid, like a piece of iron. You can't. Now you're trying to compress a block of water that's the same dimensions as that iron. You can't, because both liquids and solids really don't have any space between their atoms. Liquids have a little more space than solids, just a tiny bit more. Now liquids, they're awesome in that they have a fixed volume but no fixed shape. It's really convenient that I can take liquids like water and put it in a bottle and it fits the shape of that bottle. I cannot take a piece of iron, put it in a bottle, and fit that piece of iron if it's solid. And liquids have not a fixed shape, so it'll take the shape of this container, as I said. The last type of matter are gases. And that's where there's a lot of space between atoms, and I do mean a lot. So as shown here, we're trying to compress a solid. We can't because there's no space. But we compress a gas a lot because there's a lot of space between the gas molecules. Now, they are free to move, so like I said, they are compressible. So gas inside of a balloon, you can squeeze a balloon. If that balloon was full of iron, you could not squeeze that balloon. And gas will assume the shape and volume of their containers. So solid does not assume the shape or volume. Liquids assume the shape but not the volume. Gases assume the shape and the volume. Now here's a little quiz for you. We have three choices, A, B, and C. Which of these choices is most likely to be oxygen gas? Pause the video and think about it. And the answer is C. You can see that all the oxygen molecules, each one of these two is one oxygen molecule, are very far apart. Here we have solid oxygen as the molecules aren't far apart. Here's liquid oxygen as you have some space between the molecules. All right, how about this one? Which of these is most likely to be liquid water? A, B, or C? Think about it now. And the answer might surprise you. Is that it's A. So let's think about this. C, there's a lot of space between each water molecule, so C can't be liquid. B, there is more space between the molecules than A, but water is weird. Water is less dense as a solid than a liquid. Ice floats, and less dense means it has less mass in the same volume. So in solid water, or as we call it ice, there is more space between the molecules than in liquid water. All right, that's it for today's video. See you next time.